The last example seemed like a pretty basic one. All we were really looking to do right there was to just verify using a really basic identity that that was the case. But how about this thing? See, now this seems like a little bit more of a pain. We've got all kinds of things going on here now. We've got sine and cosines floating around. We've got cosecants and cotangents floating around. What could we possibly do? Well, there are all kinds of steps that we could take, and we like to use trigonometric identities when and where we can. However, I would like to point out that sometimes we may not recognize what to do right away. We've got a mixture of sines and cosines. So one strategy for verifying trigonometric identities sometimes is to rewrite our trigonometric functions on one side so that they look like what's on the other. So what could we do? Well, cosecant of x we recognize is going to be the same thing as 1 over sine of x. That's a reciprocal identity. And cotangent of x can also likewise be rewritten as a sine and cosine function. So let's go ahead and do that. Let's rewrite what we have on the right-hand side. Again, I'm not changing anything on the left-hand side of my function, so I'm going to leave it as sine of x over 1 minus cosine of x. But on my right-hand side, I'm going to change this to make it 1 over sine of x plus, and in this case we've got cotangent of x, and that's cosine of x divided by sine of x. So what could we do? If this were the case, of course, I can add by algebraic manipulation these two expressions on the right-hand side. So I'm going to make it 1 plus cotangent of x, cotangent, not cotangent, it's cosine, 1 plus cosine of x is divided by sine of x. And on the left-hand side, we still have sine of x over 1 minus cosine of x. And now you look at this and you scratch your head a little bit and you think, well, that hasn't helped me at all. I've got sine on the numerator of my fraction over here, 1 minus cosine of x in the denominator, and I've got 1 plus cosine of x up here in the numerator, sine of x in the denominator. How could I possibly get from one expression to the other? Well, this is where you have to use your imagination a little bit. We might note that down here we have these Pythagorean identities, and the Pythagorean identity is the only direct relationship we have for rewriting things that are in terms of cosine, in terms of sine, and the other, right? We might recognize the fact that, for example, 1 minus the square of the cosine of x would be exactly the same as the square of the sine of x. And if we can get that situation, that's a really, really helpful thing. So you might think at this point, well, is there any way I can get that from one of these expressions? So I'm going to go over here to my left-hand side. I'll notice that, well, 1 minus cosine of x algebraically is one of those differences of two squares. You don't see it? Well, here, 1 minus cosine squared x is 1 squared minus something else squared. And we know that that factors as 1 minus cosine of x times 1 plus cosine of x. And if I think about this particular situation, that's kind of helpful, right? Because I do have a 1 plus a cosine of x and a 1 minus cosine of x. Now, I can't multiply both sides by some quantity to make that happen. So instead, what I'm going to do is on my left-hand side, I'm going to multiply the numerator and denominator by 1 minus the cosine of x. So I'm going to take 1 plus the cosine of x. Pardon me there. 1 plus the cosine of x times the sine of x in the numerator. And in my denominator, I'm going to take 1 plus the cosine of x and multiply it by 1 minus cosine of x. And I'm not doing anything to the right-hand side of my equation now. So what good does this do? Well, in the denominator, we've got 1 plus cosine of x times 1 minus cosine of x, and so we know that we actually have 1 minus the square of the cosine of x in the denominator. But in the numerator, we've got 1 plus cosine of x times sine of x. So I'm just going to leave that in that factored form. I'm not going to distribute it. I could, but I don't like to do that where possible. If I can avoid having to use too many algebraic things at once, I will. Well, why would I care? Well, what do we know about the denominator now? Well, that's right. If you look at that denominator, that is this identity. 1 minus the square of cosine of x is sine squared x. And that's a really useful thing, because now we've got the expression sine of x times 1 plus cosine of x in the numerator is divided by the square of the sine of x in the denominator. And remember, we're trying to rewrite this expression on the left-hand side so that it looks exactly like the expression on the right-hand side. And we're almost home here, because we can certainly cancel a factor from the numerator with that in the denominator. We've got sine of x times sine of x in the denominator. We've got sine of x times 1 plus cosine of x. So canceling algebraically gives me 1 plus cosine of x on the left over sine of x. And on the right, that's the same statement. So this verifies that the expression sine of x over 1 minus cosine of x is exactly the same as cosecant of x times cotangent of x. And the thing that you have to get used to when we're dealing with identities like this is that, well, there are certain tricks. And this is one of those tricks right here. Sometimes when you have an addition or subtraction that's in a denominator, we can use this kind of identity, our Pythagorean identity. So this is sort of a Pythagorean identity trick to help us recognize when and where we use each of these expressions, each of these identities. So this is our Pythagorean identity trick right here, where we multiply a numerator and denominator by some common factor so that we can use our Pythagorean identity, even though it didn't look like there was one there before. All right, so more examples to come.